Welcome to this webinar on communication and navigation in the world of microfrontends. So this whole area of scalable development and microfrontends have kind of caught my fascination for a few months now. And with the current changes happening in the development environment, the speed at which the change needs to be deployed, the speed at which change needs to happen, the parallelism of it, and then getting the whole deployments up and ready at just reducing the time to market of a requirement is something that I have been working on for some time now, and it has caught my attention a bit. And then we are, as the software industry, we are also at that stage wherein there is a lot of support from the infrastructure. There is a lot of support from all the peripherals of the development area, which actually enables very quick development. At the same time, a lot of effort needs to be done in reducing all the boilerplate code that you can do, in removing the bottlenecks of development so that some fast development can happen. And that's where this whole area of scalable development comes into picture, wherein now not just looking at it as scalable from a usage perspective, scalable from a deployment perspective, automated deployments, not just there, but the whole development aspect of something, how do we make it scalable? And out of those things, while I was looking at the different areas of it, from DevOps to the front end, so one of to a large extent, microservices were already there in the backend services. And then there have been some architectural patterns that have evolved on microservices. But on the front end, we still have some frameworks, but that's more or less in terms of how do you make it independent, how do you make it modularized, right? So while looking into this, so this whole aspect of microfrontends is something that can really solve this problem. You reduce the number of merge conflicts, really do a separation of responsibility from what one particular feature does versus how do you start composing your application, how do you start removing an application out, a feature out, and then bring a feature in, and then how do you do that in scale, right? So all that really drives, and then microfrontends will actually help us drive that. And that has been the topic for us for the previous webinar, and then this also. So just for the benefit of the people who are attending this for the first time, I will very quickly, not taking more time, I'll very quickly give a precursor to this webinar so that all of us are on the same page. So we discussed that there has been some scalable movements in a lot of areas, and what is it with UI. And then we said that some of the fault lines on the UI are basically because JavaScript as a programming language itself will bring a few things with it. And the ability, there are only modules and frameworks in picture, but then not really as something which composes multiple different endpoints. So that is where how do I make UI development itself scalable? There we put a few rules, as in by telling that UI has to be scalable. We should be able to bring our own framework, so it should not be restricting users, telling that use only this framework and only then you arrive at the scalability. No, right? So we want people to bring in their own framework. We want changes in such a way that they're really localized. We want to bring in single responsibility principles. More importantly, multiple teams working on the same application should not really be stepping on each other's toes. How do we do quick releases? How do we change, modify, swap out different things? Some basic rules of it. And that's where we came to that point that, okay, microfrontends can also be one of the areas where solutions that can help us address all those issues. And then we discussed a few things about microfrontend, the importance of boundaries. The communication should not happen from a child app to another child app. That's how you maintain the boundaries. The communication should always start from a screen or a container app. So some key architectural considerations were, okay, we bring in a screen or a container app, and then we also wanted to take this differentiation between what's a build time microfrontend versus a runtime microfrontend. So build time is you take all the source codes of different thing and then compose something together. Runtime is you are really reaching out to different products or different areas of your application, which are actually hosted on a different environment. So this runtime composing of a micro frontend gives the maximum liberty in terms of how do we make it scalable. Right? And then, yeah, so the pluses and minus, I'll just go through very quick things there. So zero coupling between the child components, zero coupling between screen and the child apps, near zero, because there needs to be some kind of communication. And this aspect of it we will elaborate today. Styles from one project should not affect the another. So there is a way in which the CSS needs to be written so that we don't have unexpected results there. And then separate version control systems. Basically, the source code itself should be different. And we're also talking about runtime micro frontend, wherein I'm only looking into already deployed UI. Right? And then, so choice of what should somebody use, right? So should I be using Angular? Should I be using Vue? Should I be using React? It should not really matter. So that means that at some points, the decisions that we take from a micro front-end perspective should be should not really be based on the underlying frameworks. Rather, I should fall back onto the regular JavaScript, what JavaScript helps us, and then we looked at a few technical challenges, and then with navigation we discussed a few things about if we require individual routing. Today we'll elaborate on it, and then at that point we said that we will have a separate discussion on the navigation and communication, and that's why here we are talking about navigation and communication. So now with that precursor, I had also showed a few code of, okay, so bringing in some amount of the Webpack, bringing in some module federation, and then how do you start mounting modules? We'll take that a little further. So in today's session, we will start going through some of the theoretical aspects of it. So people who are not really familiar or who are not really hands-on, we still get to know what are the real conditions that might affect or what we should be aware of. And then intermediate, I will jump to the code also and then show different aspects of the code which will make it happen. This code is in React, but even though you do not know React, just the understanding of JavaScript is enough. And also, just not to bore you with too much of screen reading on the code, it's not really, it's very intuitive when you look at it, and then we'll split that into how to read that code separately and understand why each of it is necessary. And by that, I think we would have actually looked into the whole navigation and the communications area of it, right? So let us start from it. So with this, maybe that precursor will help you if you're not really working on a day-to-day basis on the micro front end. Maybe it will help you jog your memory on, maybe it helped you to jog your memory on what we did in the previous webinar, or at least we have a common standpoint there, right? So now from this, for me to build on the top of this, let us put a few requirements around what we call as navigation and communication between all these applications, right? So now we require individual routing needs. So each single point, each single page application will have its own routing needs. So an app which is actually a screen or a container, which is actually composing multiple different micro frontends, should not really be dictating how the routing should happen within a micro frontend, a very important distinction. So individual routing needs. So that also means that they should be free to choose what kind of routing libraries they even bring in. All right. So now, and then another requirement which guides your architectural design would be we want each of this UI to be autonomous in the sense that so each micro frontend will evolve, of course, and then it will keep adding multiple different routes to its own. That's how each can be run through a different product backlog, each feature or each micro front end that we want, and then it keeps evolving, right? So when that happens, it really needs to be autonomous so that the full control of what all marketing can do should be left to the marketing team. The full control of what all needs to happen on product listing should be left to the product listing team. So we need to provide that autonomous, a very non-breakable requirement there. And then many a times when we do navigation, it's not just that I'm only going from one micro front end to another micro front end. It can also happen that on the same screen, we have composed two different micro front ends, maybe through iframes or maybe through there are multiple ways in which we can achieve it. So I have more than one micro front end on the same screen. Then how do I handle the navigation? So to make this navigation work, we should not really be, there are many such solutions there, but one such easy way is, we do not want to be building our own custom routing library. That's not really a trivial task. So the best thing is we say that we use out of the box available routing libraries, React router, Vue router, Angular router. And then we say that each micro frontend will continue to use its own routing libraries, because all these routing libraries are all implementations of a particular spec. The kind of data that can be extracted or that can be exchanged, the kind of method overrides that you get in each of these routers would really be same across, and that's more than enough for us. And whenever we are also talking in terms of we want to build a few things on the plain JavaScript event-based things, so that I don't have to really depend, or I don't have to really know what is happening in the routing of a particular micro frontend. And when I say this micro frontend, it's not even a single level of micro frontend, right? So I have an app which composes two things, and then I have another app which takes this and composes it. Say, for example, there is product listing and product description as two different micro frontends. I take both of them and build a product micro frontend. I take this product micro frontend and a similar order micro frontend and then build a particular e-commerce website. So there is a multi-level or a multi-layered micro frontend stacking that happens, and we should be okay to have the routing work all through the whole hierarchy. Right? That is also one more interesting thing that we will look at today, and then we will see how that can be achieved. Yeah? So after all this, here we also discuss that, okay, I need some kind of routing information from my container to each of them. And then I don't want each of my micro frontend to talk to one another. So all that, okay. But then I should still be able to access each micro frontend as if either in a development environment or as if it is deployed on its own, right? I should still be able to access it like that. I need direct access. That isolation needs to still be there. Right? And while implementing this, it should be made as generic as possible. How can we make it? We can just use JavaScript-based libraries to make it happen, in the sense that I use event handlers and then maybe pass around a few functions between them, and then those functions will start to work with one another. Right? So to make this happen, we will start off with, so let us consider these 6 things as some of the guiding principles or some of the requirements that we need to meet when we say that micro frontends has its own navigation and communication. And attacking this navigation and communication and solving this becomes the most important aspect of the whole micro frontend building, basically. All right. So let us proceed with this. So some of the possible solutions is, I'll also show you that the corresponding code to say where what happens. One of the easy things to do is, okay, I say that each micro frontend, I say, okay, you can go in and then bring in routers of your own. So I put in React router for something, and then another micro frontend brings in its own React router or an Angular router, and then the versions of these routing libraries can also be different. It doesn't matter, right? So there is no real dependency between all these routing libraries. This can very easily be done because microfrontend, we are also looking at a microfrontend which is already deployed. So that means that there was a build process for a microfrontend, and that microfrontend used a library. So for that matter, the main container or the screen will have its own copy of the React router. The pricing will have its own copy of the React router, and cart will have its own copy of React router or Angular router, depending on how this cart was built. So there will be multiple copies of it, and that is what we need, right? So by putting a different library and not really restricting the library, we bring in that autonomous nature to it. And after doing that now we say that, okay, the routing within the pricing is done with the router within the pricing. Similarly for the screen and similarly for the cart. Right? So, now it basically means that on the main screen that I have, now the container can decide the routing functionalities of the container, right? If the container or the screen doesn't bring its own functionality, so the container or the screen that we have should mostly be deciding what microfrontend should it route to. And once the routing happens, then the internal routing is all handled by the microfrontend within it, right? So this is very easy. This is very easy to make, and any very basic implementation of microfrontend without even worrying about navigation would have done something like this, right? So the container or the screen through module federation knows how to go to a particular microfrontend. And then a microfrontend knows what all libraries it has. That's very easy for us to do. So now this whole idea of having the container and then having multiple things will automatically get solved there. But even before we go into the actual crux of implementing the navigation and implementing the communication between it, we need to understand a few things about how any particular routing library would start to look like. So any particular routing library will basically have two parts to it. If you have really gone into and designed very complex communication within your applications, then you would already know about this, that a routing library would have these parts to it, the history and the router part to it. Or otherwise, in most of the cases, we just take what snippet of the code does routing, put it there, and then start adding our routes below it, right? But then for us, within microfrontends, to understand this navigation, this understanding of a routing library is necessary for us. It basically has two parts to it. One is the history part, and the second is the routing part. The routing part, each of this library will do it. It knows how to show different content. So we do not want to touch that. So what we want to worry about, or what we want to focus on, especially with microfrontends and navigation, is how do we start dealing with the history aspect of this routing, right? So to just draw a mental separation of it, the history is what path and what is the next path. That's all, just about the paths. Router is when it knows a path, what is the content that needs to be shown? Content needs to be shown, so we don't want to touch this, and it's the history that we need to worry about. And interestingly, how we manage this history and how do we build some architectural guidelines around it is a very important aspect in making this microfrontends work. So let us start with this, right? So digging a little deeper into the history part of it, one part is the browser history. So the browser history is the path portion that you see on the address bar URL. Is the browser history, and manipulating the browser history will actually make changes to what you see on the address bar of an application. So the path portion of the URL to figure out what the current path is. And then there is also this hash history. Many a times within the single page, when you want to jump between it, the hash history comes into picture. But when you're working with single page application and when you have really made it into multiple smaller things, maybe you may not deal with hash histories, but browser history definitely. Now, the more important thing here is, so this starts to play a very important role in our application. That is the memory or the abstract history. So this memory or the abstract history is again one implementation of the routing history, which keeps track of the current path, but it's only in the memory of that particular module, right? It won't change the address bar for us. We need this very importantly, we need this because as we were talking about the runtime deployments of it, right? So I'll see if I can quickly go there. We were talking about the runtime deployments of it, wherein I say I have product listing and I have orders.js. I don't want to build an application wherein if I click on the product, it is completely jumping to a different application, the end user's view of it. And then the whole URL changes. I don't want it to happen like that, right? I want users to have a feeling that they're still within one application, but it's only internally that it is getting routed to different applications. So that's why if in my micro frontends, while I have composed it into a bigger application, if I use the browser history, then the user sees a jarring jump from one domain to another domain, and that is definitely not something that we need. Right? So that means that all my micro frontends internally should start using the memory history and not really the browsing history. I will show you the code changes that can lead to it, and then we will discuss that. So that means that my main container uses a browser history, and the product, or which is a micro frontend, it starts to use memory history. Right? So let me first show you that code, and then I'll come back and we will proceed further, and we will see what all needs to change. Right? So I have one code base which doesn't really implement it. It will still work, but then it doesn't really implement the micro frontend navigation the way it should. But then it's just bringing many things together, right? So let us see how such would have organized its routing, and then what should be changed. I'll show you what changes step by step so that we can handle this whole navigation. Right? So this micro frontend setup was also shown in the previous webinar, but just that now if you look at it, think of this as a container app or a screen, which is actually composing other micro frontends. And then within this, if you look at it, so there is this dashboard. So there are two things, dashboard and marketing, and then it is just bringing them together, right? So marketing has its own code there, and then the main container has its own code. So we'll just look at container and the marketing aspects of it. So if you look at it, the way this code is organized is, so there is this index, the index loads this bootstrap, not to be confused with the bootstrap CSS library. We've just named it as a bootstrap, which basically means that it's starting the mount, right? So this bootstrap does the mount, calls the mount, and then there is this app, and it's the app that has the required routing information for the marketing micro frontend. So now for the marketing micro frontend, you see that it's using browser router. So that means that that is the actual component name, but then this is actually the browser history that we are talking about. So it uses the browser history, and then it has two paths, right? Pricing and then a basic path like this. Right? So and then I also have this container, a similar structure with the container, wherein there is this index which is loading this bootstrap is loading app, and then it is this app which is basically bringing in the marketing app micro frontend and maybe some header micro frontend. And then even here you see that even this is also using the browser router. So that means that now both my screen and my corresponding micro frontend, both of them are using browser router. So that means that both of them are at the same time, maybe some race conditions at the same time, try to change the browser history, and that leads to a lot of problems. And also that whole idea of how the user looks at your, looks at your micro frontend is also important for us. Now we need to take code which looks like this, wherein both of them are using just the browser router, and then start moving towards that navigation control wherein the main container uses the browser router, and then all the micro frontend starts to use the memory history, right? So for that to be done, uh, so we need to change from the browser history to memory history of the micro frontend. Okay? So by doing this, what it specifically means is that now in the container, any links that you access within the container, then it will be affecting its own parent router, that is the container's router history, that is the container's router history. So now when I come into the product, and then within the micro frontend, if I try to access any links, then this micro frontend will access its own parent router history, that is the micro frontends. So now by bringing in different routers, basically, is helping us in some isolation. So these links know, okay, where to go and what to affect and things like that. Right? So now what we need to do is the same setup with the changed files would look something like this. So in the marketing, now I see that nothing to change on the container level, we'll come there. But then at a sub app level, if you look at it, so the index doesn't change, it's still the bootstrap. The bootstrap is loading here. And we will look at different aspects of this code. Now you see that previously what was just a small mount has now become a huge function. Through the course of this webinar, we will know what each of this is trying to do. But right now, just focus on the areas that are important right now for us. So here, instead of using, close this, and maybe I'll close this, and I'll open the bootstrap of the previous marketing so that we know what changed, right? So now previously it was just when it bootstraps, load this app, right? But now in the new change, now if I open this bootstrap, now along with this, I'm now first creating a memory history object from the history. This history is actually within your React DOM, so you will get it. So I'm using this create memory history, and then I'm creating this memory history, okay? And then while loading the app, previously it was just the app, I'm passing this history object to the app, and then within the app, I now start to access this history. Okay? And in the app, previously it was a browser router. Now that browser router is changed to router. Router is the basic implementation, the in-memory or the memory router. And to this router, I am passing a history object. Yeah? So from the previous implementation, we have done two changes to this. One is change the browser history to memory history. That's what happened here. Browser history got changed to router, which is the memory history. And then we provided an initial version of the history wherein from the bootstrap, we created an object of the history, memory history, and then we assigned to it, and then we pass that as a property to the main app that is getting loaded. Okay. So just by doing this, we have now started to move towards the actual implementation of how we wanted our container to have a browser history and the micro frontends to have memory history. But just doing this will bring in some problems to us in the navigation. So think that the rest of the code was not there. We only changed these two things, created a history object, passed it to the app, changed it from browser router to a regular router. Right? So now what happens if the user opens the actual page, the root page, the container's browser history, so has this, and at this point, the sub app micro frontend is not yet loaded. But on that, when they click on the product listing, so at that point, so now who is accessing the browser history? The browser history is being accessed by the main container. So the browser history will still continue to have slash or the home location, but then the micro frontend has already initialized its own memory history, and within the memory history, the root has become slash product listing. So the user will now continue to see only the home on the browser address and not really the product listing, because this micro front end is not really changing the product history. We need to correct it. We will correct it step by step. So this is the first step wherein we have now changed the routers on the main app which is composing and then the subsequent smaller. Now the second step is, now you see that there is a problem here, right? So it seems like we have only stayed in the same page, but we have actually changed the whole thing, gone into a micro front end. Now I want the proper product listing. I want my back buttons to work well, but now all that is broken at this point, yeah, until we take further steps to solve it. So now the next step would be, now I need to somehow start syncing the containers history and the micro frontends history. What do I mean by that? What do I mean is, now the micro frontend knows that it has moved to product listing, but the main container does not know. That is why the browser history is not updated. So what I need to do here is, now micro frontend, whenever the user clicks on a link governed by micro frontend, that is the memory history, then now it has to communicate the change to the main container or the screen or its parent, telling that, okay, somebody has clicked on this, and because I'm not managing the browser history, now you go and deal with the browser history, right? So it has to give that communication back to the container. And then the container's browser history should update the current path, right? See, now here we're not really looking at the routing part of it. We're only looking at how is this link and the history being managed. So to make this communication happen, what was one of the rules that we kept? We do not want to bring in special routing, and we want to keep this as decoupled as possible. So what the container can do is, this container can actually pass a function to the micro frontend. It just becomes like an event callback. Yeah, it's basically passing a callback to the micro frontend. And then the micro frontend, after updating its memory history, it needs to invoke this onNavigate or whatever function that the container passes and inform to update the browser history. So now when we do this, now it means that we have accessed this part of it wherein the container talks to the micro frontend, the micro frontend replies back to the container. Right? Now let us start seeing how that code would look. So now what did we want? We wanted the container which is actually calling the components. So while calling this component, previously in the code without this navigation, first I'll show that and then I'll show how that code changes to bring in those aspects. Previously with this, while it calls the marketing, you see that all it does is it just calls ref.current and then it loads the marketing app. That's all it would do. Okay. Now within this navigation, now what happens? Within this use effect, now what do we do now? We create a function on navigate. Okay, we'll discuss about this. It creates a function on navigate and then it passes that to the mount function of the container. So now within the container, within the micro frontend, now I see that this micro frontend, whenever that mount call happens for the micro frontend, it gets this function called as onNavigate. So we now have started to link the communication from the main container to the micro frontend by passing this onNavigate function. So now this onNavigate callback Now we had this history, which was basically this create memory history. I will come to this. We will see why this is important. It had a memory history, and any history implementation would actually give us a listen callback. And then all we need to do is whatever function we got as a callback from the main container, we pass it and then we register that with our history changes. So that means that in this create memory history, whenever a change happens on the history, now it is going to call on navigate because now I have registered with the history. And then some things about some error checking in terms of, so only if this on navigate is there, then I want to call this history and all that, right? So now what is this on navigate doing? Now let us go back to the main container and then let us see what it does, right? So now if you look at the main container, in this on navigate, so now what happens? Who is calling this on navigate? The microfrontend is calling because I have passed this on navigate. When does it call? Whenever the history change happens. Where is the history change happening? It is happening in the memory router of the microfrontend. But I want that history change to happen in the browser history, which is in the container. So here, now here I say, so it is accepting a path name. Basically, whenever a history change happens in the previous listen that this history listen that happens, no? In the history listen, when it calls this, it passes the whole location object. Yeah, you can take the whole location object and then deal with it, but we are only interested in the path name of it. So we will take the location object. So this notation, right, the new JavaScript notations. So what it's basically doing is the whole location object has other parameters, right, in the object. So it has something called as hash, it has some key, it has some location, it has some other description and things like that. I don't want all of them. What I'm extracting the path name from it, creating that path name, and then I'm renaming the path name to next path name is what it basically means, because I don't want this name clash with the path name. So we say we want the next path name. And so now what is the history here? The history is use history that we have. The history is the browser history. The browser is, that's the router that is there in the container. So now the browser history, I am pushing the path name that I got from the microfrontend. Cool. So in the microfrontend, it is passing this on navigate. On navigate gets called every time the path changes. It is sending the new path. And as soon as it sends the new path, now the main container updates its history and pushes the new path into the whole stack of paths that it has. So this is cool, very simple. And along with this, we do some name change because so every time the history changes, the next part of it, we have the listen and then it starts to go into a loop. I will explain this. So to stop that loop, we say that, okay, if there is no change, then don't keep talking to yourself. Only if there is a change, do this push, otherwise exit out. So this is just to break that loop. Why this loop happens, when we discuss the next thing, we will understand why this loop happens. So this is cool. Now we have very easily solved this aspect of the communication, wherein now I say that the microfrontend is now coming back to the browser. So at this point, we have solved the first problem that we had, wherein we wanted this change to happen, right? Wanted the browser change to happen. So now after we do this, there is just a small change. After we do this, because we have changed the way the microfrontend works. In the microfrontend, we have told that while mounting, it requires this on navigate. So accessing this marketing microfrontend specifically will start to break because it would not have passed this on navigate. So we go to we start to just create a regular dummy navigate and then start passing with it, and then that's all we need to do, and then it will start working, right? Otherwise it's going to say that, okay, somebody did not pass this navigate when you directly try to access it, when the direct mount happens, and then it starts to worry about it, right? So we just need to pass a dummy object also for the navigate. Now we are at step 2.3, right? So now at step 2.3, Now I need to, we solved one problem of it. That is, we solved this communication of microfrontend to the container, going back and updating, but we have not solved the second aspect wherein now the containers can start communicating with the microfrontend through a callback. Even though the callback is passed from the container to the microfrontend, the communication is happening from the microfrontend to the container. We don't have anything wherein the container can start talking to the microfrontend. Now what do we need to do? Solution is simple. The same callback implementation that we did for a container to a microfrontend, we do the reverse of it. Right? So how do we do it? First, if you look at a without navigation implementation, after the mount, right? The main container app has no communication at all, or it has no handle about, okay, it has just given complete control of it back to complete control to the micro frontend. Now how can we solve this? Excuse me. Now how can we solve this? Very easy. We go into the container app, and then what do we do is, as soon as we call the mount, we need to expect the micro frontend to pass back, just like how we passed on navigate function to the micro frontend. We want the micro frontend to pass back a callback so that the container app can now start communicating with the micro frontend. Now look at this. So what do I do on the mount of it? I am only returning whenever the mount call happens, that the main container will do. We are returning back another callback. If you look at this callback, it is actually the same implementation that we have on the navigate, right? So now on navigate, what is it doing? It is doing a history push of something. Now I want this parent navigate also to do a history push, but this is happening at the, so it's almost like we are setting up a duplex communication between the main container and the micro frontend that we have, right? So now we say on navigate, it takes this path and then it does a history push here, right? And then we see that, so now we see that whenever, now what do we need to do? Just like how we added on navigate to the history listen of the micro frontend, we need to do the same thing at the main container level, wherein in the main container history listen, we call the on parent navigate, which is of the micro frontend basically. The naming can get confusing, but then it's actually, it's not the history's parent, but it's the micro frontend's parent, which is the current container, right? So we add the history listen to the parent, and then it gets called. So that's pretty much it. Very cool implementation there. So now what happens? Micro frontend is using on navigate, and then the container is using on parent navigate. And now we have set up a duplex communication between the container and the micro frontend here. Okay. So now after doing this, now what you will see is, okay, so if the main container is handling the browser, and if the micro frontends are handling the memory browser, now we are limiting it in terms of how can it become a multi-tiered application. So what do I mean by that? Then does it mean that we can have only one encompassing container which handles browser and everybody else needs to handle only the memory router? No, that will limit me, because like how I said, my product app itself can be a composition of multiple micro frontends. That means that now if I don't worry about the bigger e-commerce application, my product itself needs to have browser history, right? So let me draw this out for easier understanding. So now if I say that, say for example, I have product, and this product is composed of two different things, say listing and description. So if it's only one level, it's easy for me to tell, okay, hey, listing, you go and start using memory router, sorry. Yeah. And description, you start using memory router. And then product, you start using browser router, yeah, or browser history, yeah, memory history and browser history. Yes, yeah, browser router, right? So what if I want to put this in a bigger e-commerce application? So now I have an e-commerce application. So this e-commerce application has no idea that, okay, there is a listing and description and all that. So this e-commerce, because it is the shell, now it will start implementing its own browser router. Okay? And then this e-commerce will start to call the product. But now we see that the product is also using browser router. So it's very limiting that way. I cannot really have a multi-tiered implementation of this navigation and communication. So to solve this, it's very easy to solve basically. All we need to do is we need to provide the browser history if it is not invoked through a parent app. Let me show you the code. It's easier to explain through the code there. Now what we do here is in the marketing, in the bootstrap, now what am I saying here? So you have this on navigate. So if this on navigate is there, then it automatically creates this history. But then if the on navigate is not there, then I want some default history that needs to be passed to this mount, right? So now how does that default history get passed? So this default history, we need to make changes. We need to make those changes and then put those. Yeah. So we need to send a default history, which is actually, now if you look at it, if it's a direct mount of this, right? So this mount can be called from two places. One, the overall shell application calls the mount. We saw that, wherein here it is trying to call the mount of the particular app, right? So either this, or when the app is directly loaded, the mount gets called, right? So when it directly gets loaded, what am I saying? I am creating a default history, which is the browser history. And so along with the memory history, there is a default browser history. Sending this default browser history. And then when does the default browser history get created? When I directly access it. So if the browser history is not there, then it goes and creates the memory history. This is a very important implementation to make a multi-tiered application present. So now coming back to this diagram here. So now I say this browser router will get initialized when we access it directly, right? Otherwise, the e-commerce will, otherwise, if called from a parent app, then we initialize the memory router. So if this becomes our whole everywhere, wherever we want, wherever we say we want our micro frontend to work, so we keep putting this logic. So now we make it really multi-tiered, wherein now even on the top of the e-commerce, maybe I can put one more which says a Uber application, right? So maybe this has e-commerce and insurance and anything, right? So the whole bank, or maybe this is the Paytms for you, right? Let me call it as like Paytms. I don't know what Paytm is doing, but I'll say like Paytms, wherein you have one e-commerce and then you also have maybe a similar front end, which is for maybe the mutual fund investing, right? Mutual fund investing, right? So now you see how it can easily start to become multi-tiered, right? So if you call this e-commerce directly, then it will initialize a browser router. If you call this e-commerce through a Uber app like the Paytms of it, then it will initialize the memory router. Similarly, the product, excuse me, similarly, the product It will install, it will initialize the browser router, or it will initialize the parent app. So by doing this, by putting this creation of a browser history when called directly is an important step for us in moving towards implementing a multi-tiered micro-front-end navigation. That is all it is. So now if you look at it, in this whole discussion of navigation, we did not move outside of this file, which is basically doing the mount and then handling this navigate functionality. So now extending the same thing further for any communication that you want between the container and this one, have an event callback, register it, make that as a duplex communication, one to the other and other to the one, and then you have really implemented a multi-tiered navigation. Otherwise, your micro frontend half-hearted implementation of a micro frontend will only mean that clicking on a link is taking you to another application. That is not what we want. We want all of it to work as a single unit if composed together. If you take them out also, it should work as a single unit. The browser history should be maintained always. The user should be able to do back and back and back and back, and then the whole navigation should work the same way. Otherwise, you're only changing the whole domain itself, and then is it just like, okay, I provide a link and then I go to different thing? No, it is very important to set up this multi-tiered navigation so that you start to handle your micro front-end communication in a very easy way. But then sometimes what happens, maybe another discussion for another day, I may want to expose e-commerce as a separate application, but I may not want to expose product itself as a separate application. So there are other ways of introducing auth, making it not work, and then putting some VPN controls around it in the whole way that you deploy. And we can start to solve that. Maybe in a different discussion, we can go towards that. But at this point, right now, everything can be accessed, but that's okay for now, right? So just winding the discussion up there. So now the needs, individual routing, yes, they're all different routers. It can come from any library, or the routers can come from any library. Are they autonomous? Yes. Can we have more than one type of routers? Yes. Have we used an out-of-the-box implementation? Yes. Have we provided direct access? Yes, very important when we want to make it multi-tiered. Is the solution generic enough? Yes, all we did was write an event handler and then write a callback, event handlers, and just pass it around. That is all we did, right? Use of any libraries, browser history for the parent app, memory history for micro frontends. If called from a parent app, micro frontend is directly called, then it uses browser history. Make the parent and child app exchange event handlers. That's all it is. So this completes the whole setup of navigation and communication when it comes to micro frontends. But implementing all this routing throughout this is a very important step in setting this up. But what you see here is, once you set this up, that's all you need to do. Maybe you can even package that as a separate library and then start importing that library in all the places so that everybody in the org is able to use the same kind of routing information, right? Okay, so at this point, so one of the questions is, can I take this auth and then pass it on to all the particular micro frontends? Yes, auth, we will start to discuss it a little differently, but then it still follows a similar kind of communication, wherein there is some auth element that gets shared, and we in all the micro frontend we need to expect that auth element or a token. And when we discuss the auth for micro frontends, even that is an interesting discussion that will kind of round up the whole thing. So at that point, but keep the auth aside a little bit. You only think in terms of what if I want to share some data between the main container and the micro frontend. Auth data too, but then I want to share the data between set up a similar kind of thing, populate any data that you want, make the micro front-end work on that data, and then start showing that data. So that way, it becomes very easy to set up this communication. And this also makes sure that now you see that, so all this is happening through the mount, right? So now who is calling the mount? It's only the container. So we will never have a condition which basically, so now these apps don't talk to one another because there is no root or there is no linkage between these two apps. And all the things are happening through the mount, through some event callbacks between the composing app and the micro frontend. So we can keep that communication really segregated and we can keep that really clean. And once we set this up, now every team can start bringing in their own micro frontend, provide these kind of routing and navigation controls, and then we are on our way to implement a full-fledged micro frontend implementation of an application.